When you look at a photo, have you ever stopped to think about what a computer actually sees? Because it's definitely not people or places or things. Nope. It's something way more fundamental. So let's dive in and figure out how machines really perceive our world.
So on the left, that's our world, right? When we look at a picture, we see the story, we see the context, people, roads, trees. But for a computer, what it sees is on the right. It's just a grid of numbers. That's it, a completely different language.
And that's the big question, isn't it? How in the world does that rich, visual scene that we experience get translated into a simple grid of numbers that a machine can actually understand? Well, that's exactly what we're going to break down.
It all comes down to one single core concept, the pixel. It's just short for picture element, and you can think of it like the indivisible atom of any digital image. Everything you see on a screen is built from these tiny little dots.
And what's wild is that each pixel is incredibly simple. It's basically just a tiny box that holds only one piece of information, a single number. That's it. So let's just grab one of those numbers, say 128. This isn't just some random value. This number actually represents something real. In this case, it's telling us about a specific shade of gray. Now, these numbers don't just go on forever. They exist within a very specific range, from 0 all the way up to 255. That gives us 256 possible values, which, not so coincidentally, is exactly what you can represent with 8 bits of computer data. Okay, so here's where it all connects. That number 0, it means no light, and we see that as pure black. Crank it all the way up to 255, that means maximum light, which looks like pure white. And a number right in the middle, like 128, yep, that's your medium gray. This really is the whole idea in a nutshell. It's a direct relationship. Every single time that number changes, the shade of gray that we see changes right along with it. It's that simple. All right, so we get it for 1 pixel. But now I want you to scale that idea way up. Imagine that same exact logic, that a number equals a shade, being applied to every single one of the thousands, or even millions, of pixels that make up the whole picture. And this is what you get. This is what the computer truly sees. It's not a picture, it's a matrix. It's a giant grid of numbers where every single cell is just a value representing the brightness of that one specific spot. And this is the most important takeaway. For a computer, there is no difference between this grid of numbers and the picture itself. To the machine, this matrix is the image. They are the exact same thing. So you might be thinking, okay, cool, it's numbers. Why do I care? Well, here's why. This is the whole game. Because once you've turned a picture into nothing more than a collection of numbers, you can start doing math on it. And that changes everything. All of a sudden, the floodgates just swing wide open. We can do incredible things. We can average numbers to blur an image. We can find big differences between them to detect edges. We can increase all their values to enhance the contrast. And the really big one? We can feed these giant grids of numbers into AI models and literally teach them to see. And that leaves us with this final, really powerful thought. Computer vision, when you get right down to it, isn't really about images in the way that we think about them. It's about performing incredibly clever mathematics on massive grids of numbers. And that just makes you wonder, what can we make those numbers do next?